And off we go. So welcome to episode 3 of the 3D Print Doctor. Hi for those people who have arrived. We'll probably get some dribblers in, being last week of the term. Everybody's probably madly rushing around, so don't expect a huge number of people to be chiming in live today, but expect you to be able to look at this one later on. First of all, I'd like to acknowledge country and those people who we're on the Medical land here in at Everleigh Alexandria Way, and acknowledge elders past, present and emerging. And anybody who will be watching this today live or in the future as a recording of Aboriginal heritage. So today we're going to be actually having a look at a few weird little things with filament loading and unloading. We're going to look at the changing of the nozzle and a few pitfalls that you can run into, especially because they're two temperatures of the two nozzle, why they're two temperatures and why you use them and when you shouldn't use them. And one of the questions that I'm addressing here is people are asking filament types and where to purchase. So we're going to finish up with that today as well. So let's have a look at the actual printer itself and changing over the filament. Now, I'm going to do that in conjunction. So this episode might actually be a little short one. I'm going to do the filament changeover in conjunction with the changing of the nozzle. If you ever have to change the nozzle, and a few rookie mistakes that can happen when you're printing, and it tends not to happen too much on the Adventurer 4, but I have seen it happen, is if you don't get a good adhesion because you haven't leveled properly, or something's moved and the print nozzle is a distance away from the actual print head and you don't get a good adhesion. What can happen sometimes is that you get part of the print laying down and then all of a sudden it'll break away from the print bed, but it'll keep printing. And what it ends up doing is just pushing out filament in the one spot. You end up with a blob that can actually gunge up right around the nozzle and start to stick to the nozzle. It is really difficult to get off if you leave it like that. So it's a good idea to sort of check when you're doing your 3D prints that it has adhered well. And if you have to leave, then let it go. Most of the time, if it's adhered, you're good. But occasionally it'll snap off and break away. If that happens and you end up with that blob and it's stuck to the nozzle, go through a heat cycle to be able to pry it away, and then go through a full filament changeover and then purge the filament. I'll show you what I mean by purging, etc. in a little bit with that. So we'll do that and I'll give you a bit of an idea of how that works. But one of the things that I wanted to go through today was how to change over the actual nozzle. Now, if any of you had the little Inventor, the purple printer prior to this one, you will have known that the changing of the nozzle, or you may luckily have never had to experience it, but if you had to send it off, it involved screwdrivers and a whole lot of mucking around. It was a difficult thing to change over. I got it pretty quick down to about 5-10 minutes to change it over, but it was difficult. It wasn't a DIY job. It took quite a bit of work to get that full hot end out, put back in, connected back up again. The Adventurer 4 is absolutely amazing for doing that. However, we'll go through the actual nozzles. The nozzle is really cool. That's all it is. It's a tiny little nozzle, slides into the actual print head, and there's a few clips that we use. Once it goes in, there's a little electrical connection there, and it goes in. This particular one you may be able to see on there is 265 degrees Celsius, and it's a 0.4 nozzle. There are 4 different nozzles that you can buy to put in this, and they're really cheap in terms of they're sub $50. I think they're closer to $35 is the whole unit. Now, that is your hot end. It's the feeder guide. It is the nozzle. It's all in one go. It's almost as cheap as just buying nozzles that we used to replace and screw in. And the nice thing about this is anybody can really do it. This is the really nice thing about it. Now, why do we have the 2 different temperatures? The reason why we have the 2 different temperatures is different filaments require different temperatures to melt correctly and adhere correctly, and that's why we have the 2 different nozzles. PLA works really good with the 240 Celsius nozzle. And here is a little rookie mistake that I only just recently myself found. And we're going to go through that when we do the filament changeover. If you use the 265 nozzle with PLA, it wants to heat up to the full 265, which is too hot for PLA. It will start to burn to a certain extent. And if you heat cycle the same piece of PLA over and over again, it will start to harden like glass. And you can ruin your nozzle. I almost ruined the nozzle in this one, trying to put PLA through the 265, kept reheating it, heated it up too much, and I actually had to clear it. I've got some little 0.4 millimetre drills. They're tiny as, got them off eBay, and I used that and I eventually resurrected the 265 nozzle after I realised what I had done. The other thing that you've got to do is when we do a nozzle changeover is you must make sure that you select the right temperature and diameter, that's the nozzle diameter, nozzle. The previous firmware from memory actually detected it when you put and swapped it over and say, you've got the wrong nozzle in, and you would have to actually swap it over and change it. The new firmware, I think they've dropped that out because I'm finding I can put in any nozzle and it'll actually think it's got that nozzle in. You have to swap it over. I am reading this and it's a little bit cryptic when you go through the menus, but I'm changing it early rather than later now, and I'll show you that on the thing. We've got a few people that have dived in at the last minute. Thank you for coming up and looking at us. So what I'm going to go through now is the process of dropping out the filament. You must unload the filament before you try to actually remove the nozzle, because if you don't, what you'll do is you'll pull it out and the filament will be stuck and you can't get it out because it is melted all the way through. You can get it out, but it's a real juggling act. And I did that once and went, oh my God, what have I done? It took me a little while to get it fixed up. So don't do it without unloading the filament. Another thing is last Friday, I went down and it was simply because I was in the area. I dropped into Shan, who was on here, not here today. She was down at, I think it was Newbridge Heights Primary School, and she had some of the old purple printers and using them there. And we got all three of them up working nicely. But she had issues with the bed's not adhering. That was a leveling issue. That's at 3 important. Make sure it's level, level, level. And bed adhesion is the thing that's going to help. But you do need to make sure that you've got everything working with you, and filament is what I'm trying to get to here. Unload your filament over the holidays. Don't leave it in the printer. It will probably not cause you any problems with these new printers, but it can sit in there and give you trouble the next time you start if you get yourself out of sequence. So a little rule of thumb that I do like to use is if I'm not using my printer for any length of time, I will unload the filament so that the nozzle doesn't clog up or cause any problem. The filament can get brittle. Now, here's the weird thing, and I think I said this in one of the episodes prior. Filament is hygroscopic, which means it absorbs water. Now, physically or biological or whatever it is, it goes against what you would think. If you add water to something, it usually makes it soft. When you add water to or moisture to the filament, it actually makes it brittle. How you fix it up? You throw it in the oven in any sort of oven, I think at about 100 degrees for 3 or 4 hours. That will dry it out, and then your filament usually is nice and flexible again and you can use it. Weird, but that's the way things work. So what we're going to do now is I'm going to swap over here so I can get to it so that you can see the camera. And I'm going to change cameras, which I should do first of all, to switch camera. Good one. Okay, so we can see everything that's going on here. This is the print head where the nozzle is underneath. Here's the screen on the side and the filaments around on the right-hand side as I'm seeing it. I hope I've got my left working out nicely here. So what we're going to do to start off with is go into maintenance, and in maintenance it'll have change extruder, it's called. So when I go to change extruder, it doesn't do a real lot, but give me a graphic of the possible nozzles that we could be putting in. Now, I know I've got a 240-degree nozzle in there, and I'm going to swap it to a 265 model, the 265 degrees Celsius. So the trick I've worked out now is you need to select this before you go in and then check to make sure that it's held when you fix things up. Now, to go through, I'm going to select the 265.4 nozzle and then go next. This is a little step that you can get caught at. It's like that complete when you're doing the loading of the filament. You press it too early, it hasn't actually completed. So you've got to read the instructions, boys. All right? Okay? After installing the new nozzle, please make the offset according to blah, blah, blah. I've never had to do that, so I don't even do it. But what it doesn't really give you an idea about is turn the printer off to remove the nozzle. But the one thing it also doesn't do is tell you to unload the filament. So we've got to go back and have a bit of an idea of what we're doing. So we're going to go into prepare filament, and I'm going to just go into change. It's the easiest way to do it. And we're going to change the actual filament over. But all we're going to do is let the unload sequence happen. Once the unload sequence has happened, we are then going to simply go through and turn the machine off, remove the nozzle, change it over with the new nozzle, and then we'll turn the machine back on. We'll go into the change nozzle section, and we will make sure that it's got the right nozzle, because I started using the wrong temperature software with the alternate nozzle, and it did cause some issues. So that's almost up to temperature now. It'll start to spit out the filament on the side here. Now that's feeding that out now. Yeah, you can just see it coming out. I tend to just sort of hold it and keep it away, and then it'll pop out. You can leave that sitting on the side. That's all you need to do there. You would have noticed, see how we've got a little bit of filament that's come out? What they do to make sure that they don't end up with any filament left inside this part of the nozzle here is they actually extrude a bit of filament and then quickly pull it out. If you've got any of the little Inventor printers, the purple ones prior to this, when you unload the filament, you've got to actually push down the lever and then push the filament in by hand and then pull it out. It's the best way to keep your nozzle going for a long time. Now we've got rid of that, I'm going to turn it off. Printer's off now. We've got rid of our buzz as well. And this is the magical trick of the Adventurer 4 is I've got two clips in here that you should be able to see I'm grabbing. I'm going to squeeze those in, and then I can pull the nozzle out. Be aware right at this moment that that nozzle is still quite warm. So be careful to do this immediately. Have a little touch about it. If you've got asbestos fingers like me, I've been working with hot metals for years and my fingers are almost dead, so it doesn't actually affect me. Let me see if I can get in here and you can watch me do it as we go. So I'm going to squeeze and pull. You just wriggle it out and it comes out that easy. Just squeeze, give it a little wriggle and it'll pop out. Okay,
Greg, so your head was in the way just as you did that. You might want to just do that again.
Thank you. Okay, so head out of the way. Thank you. Squeeze, can we see now? Squeeze those two tabs and then wriggle and pull, and that'll come out nicely. There's no filament in there. There's nothing sort of getting in the way. And now we can swap it over. Grab the other nozzle and it'll be nice and cool so you won't have any problems. Make sure that you can see the indicators of 0.4265 and you'll just jiggle it around until it finds its slot. It basically, the front here lines up with the fan nozzle. That's the little extruding nozzle. Again, squeeze and push until you get a nice click and then try and pull it out. You could probably just push it in as well. I tend to not like doing that with plastics. I like squeezing it because as you're pushing it past the little tabs, they do wear over time. So I tend to squeeze and push. Check that it's not going to come out and you can give it a reasonable amount of a pull. If it pops out, just make sure that you've pushed it in enough. I've actually had it that I didn't quite get. I got it on one side, but not the other. Make sure it's in, I'm clipped in on both sides. Now, once that's clipped in, we can go back now and turn the printer back on again. Here's the next thing that we're looking at. This is a really good example of, here's the filament that's come out. And we've got this little very thin section. It gives you a really good idea of how much of a difference there is between the full thickness filament and how thick it is when it gets extruded through that 0.4 millimetre. Here's a good one there. I do not want to try and insert this into the filament feed in this state. I will actually cut, or what I tend to do is simply just break it off, and it's ready to go. So I just give it a little twist, break off 1/2 inch to 1 inch so that it's a nice diameter and you don't have a little bulge or anything there, because that can cause issues. This print is pretty robust in that respect. So you shouldn't have a problem. So now I'm just going to go through, and I don't want to maintain, I want to prepare. So I'm going to prepare, I'm going to go to filament. I'll do quick with my fingers, and I'm just going to go to load. Now it's going to heat up. I get ahead of the game a little bit. Make sure that when you've got the filament that you don't have it cross over itself. So I pull it out. Find the little yellow arrow, find the little hole underneath and feed that in. We've got to wait for the heating up, and as you can see, this printer heats up pretty quick. I have had printers that have taken 5 minutes to get to this temperature, and it becomes quite boring. While you're there too, guys, if you've got any questions, throw them in the chat for us. Between Stu and myself, we'll keep an eye on it. We need to know what you want to know about the printers. Now, it's sitting there and saying, put the filament into the holder, so I've done that. Press next, and it'll pick it up. If you've got a tiny bit of pressure, you'll actually feel it pull through your fingers. Let it do that. And then the filament will come up, and if you've got a colour rather than white, you can actually see it travelling through the white Bowden tube. That's this little tube there. This tube here. You'll start to see the filament coming through. Now, it does take up to a couple of minutes, and that is don't press complete until you start to see the filament coming out of the nozzle itself. So we'll just sit there and wait a couple of minutes. Once that filament comes out, you will then be in a position where you've swapped it over. But then what we're going to do, and what we probably should have done before we put the filament in, was check that we've got the right temperature nozzle in the system. We'll go and do that after we find it coming out. Come on, you can get there. Here we come. Right, okay. I don't know why there's red in there. Okay, here we come, and a little bit of white. I might have had a play with something. I can't remember doing that. Okay, here we are. Let that feed through, and you'll notice if I put a little bit of a down slant on this, there we go. And it gives you a nice little pool of filament down the bottom. When you're swapping over filament, I like to have a little pool. I'm happy with that now, so I'm going to press complete. I'll dive in and just grab that and take it off, and that becomes a little bit that some of the kids will probably want to play with. And now what I just want to go in and check is with my maintenance and the changing this over, that I do have the 0.4265 degrees Celsius selected in the software, as well as it being the 0.4265 nozzle that's in there. And then I can go next, complete, we're done. It's probably a good idea actually it's a very good idea if you change over the nozzle, because the nozzles will have sometimes a little bit of height difference, and that's what that Z height is. It's probably quicker, but you don't know what this distance is, because it really isn't telling you anything. Do a print level at this point in time just to make sure that you've got the right distances, and you'll find you'll probably have a little bit of adjustment when you swap over the nozzle. Now, this is the next thing that I want to go through, and I'm going to go back to, because we're going to move on to filaments, etc. now. And why I'm using the wrong thing. So let me swap the camera back. Any questions with what we've just done? Swap over the nozzle, etc.
There's nothing on there so far, but there's not a huge group here with us. So if people have a question, they could probably turn their mic on and ask away, yeah? Yeah, I've got no problems with that. So just chime in, guys, and have a chat with us. It's really good. Filament types. We've got the basic filaments that you're actually getting, and we did have the question from one of you last week was, where do I buy new filament and where from? You can get it on EdBuy. You will find that both MTA and Bilby 3D have, or 3D Bilby, I forget which way it is, Bilby 3D, have both got filaments on there. This particular product by Bilby we were using extensively with the
the purple printers, and it is really good quality. This is extremely cheap as well. It's under $24 for a 1 kilo spool. Really, really good stuff to actually use. I've had no problems in it. There's virtually zero smell. I would almost say there is zero smell with it. So it's not giving off that sort of sweet smell that cornstarch tends to give off. They've basically eliminated most of the aromas. Really good quality. The MTA tends to sell the Flash Forge filament, which again is a good quality filament again, a little bit more expensive. And then the different filaments that you may be experiencing or want to possibly look at. In your classroom, if all you're doing is iterative prototypes, which is what 90% of your 3D printing is, you are printing stuff that you might use, but most of it is experimental and you're trying to get something that works for you. PLA is still probably the best. It's the cheapest product to use. It's supposedly biodegradable, but it tends to last forever nowadays. It's quite durable. But you will find that it is just good to use in the classroom. It's always good when you've got anything like this to use it in a ventilated space. But with PLA, it really doesn't make a big difference. It's not toxic. Where you then start looking at different filaments, ABS used to be the most used filament, and ABS is the same, and somebody can come up with what ABS stands for. I do know, but I've forgotten. It's Athol something or other. It's the same plastic that Lego used to use in their blocks. It's a petrol-based plastic, and so therefore, when you're using it, it does give off a pungent odour. I have actually got headaches when I've used ABS in a closed space, so I tend to not use it a real lot, and especially if anybody else is in the room. ABS theoretically should be slightly stronger than PLA, but the differences between them nowadays are negligible. If you had a plastic that, or an object that you were going to use in the sun, ABS would last longer than PLA. But a better product than ABS would be to use PETG. Now, PETG, or PET bottles, you might remember. PET bottles are the same bottles that you buy your Coke in, etc., and they're fully recyclable. ABS is fully recyclable as well, and PLA you can actually reuse. If you wanted to, here, great project for a Year 11, 12 design technology would be create, and there's a whole pile of these sitting on the internet, create a PET recycler, and you can actually cut a bottle into thin strips and put it through a little mould that makes it into the 1.7 filament. Big job. The other one would be to take all of your offcuts, and I end up with heaps of them with all the experiments that I do, and remelt it into a filament that's 1.7 and reuse it. Some companies do this. They're quite expensive, the little items that you get in, but I would love to be able to get that going and have an affordable product in schools. PET and ABS, however, about double the price you will pay for PLA. Hence, most people use PLA over these two. If you're wanting to have an end product, you prototype on PLA and then finish it off in PET, and there's different versions of PET as well, or ABS. Now, if you get a little ambitious, you can, there is this one here, which is flexible. It is nice and spongy. It's really, really nice. These printers, because they use Bowden feeds, tend not to like flexible filament. There is a set of settings. I have tested it and it works reasonably well. And I will put the link up on the screen in the resources, or in the resources section, in the top tips. Or even I'll put a link in this particular segment's episode to give you an idea of a guy that's gone through the whole process of getting the settings correct with the FlashForge printer software, and you can print in flexible print. Really good, but be careful. What I'm about to say is the same thing. There is also, and I will get onto this one now, and then I'll wind back a bit. This is copper. What it is copper that has been powderized and then mixed in with PLA. And when you print it, you can polish it up. It's quite heavy, really expensive. This is about quadruple the price of PLA, and it's not as big a thing. This is only a 600 gram spool, so you don't get as much. but there is copper, brass, bronze, there's stainless steel. You can have a steel or an iron or what they call a magnetic print. You can also get in, what is it? Electric, what I'll think of it, conductive filaments as well. And what you could do with that was print a circuit board and then put the conductive filament, which will give you the circuit lines. How you solder it? I haven't played with it. I do have some conductive filament. I simply haven't had time. Really good experiment to play with. That would work better with a two-headed printer. And there is a really good flash forward with a DX so that they are completely independent heads so that they don't have the inherent problems of twin head printers, which are the one head knocks the other one and then you have a failed print. Most people who have the older twin heads tend to take one of the nozzles out, so it's a bit of a shame. Now, where I was getting to with the flexible is there's also one filament which is wood, and it is again basically sawdust, which has been bonded and put into a filament form with PLA, and it will print a really good-looking object that's filament. And if you've got the little Guardians of the Galaxy guy, who is he? The tree. Everyone does that one, and it looks fantastic when you do it in wood. Now, all of these, what I call exotic prints, especially the metals, the wood, those sorts of prints, metal, highly abrasive. The wood, as wood does, if it gets out into the atmosphere, it starts to swell because it takes in moisture. What you do whenever you use these sorts of exotic filaments is make sure basically I say immediately, when it finishes printing, you withdraw that filament, then put in some PLA and let it purge, just let it feel through and clean out that nozzle. It makes a huge difference. If you leave it in there, especially the wood, these aren't quite as bad. The wood is the worst. You leave it in there, it'll block up in a couple of hours and your nozzle is useless and it's almost impossible to fix up and get back again. So if you use the wood filament, and I'm not saying don't because it's a fantastic product at the end, make sure that you're there for the end and you withdraw it. The bronze, copper, brass, the steels, etc., I would do the same thing. You will wear out your nozzles. They will become 0.5 millimetre nozzles pretty quick and you'll end up with some really weird prints because the software won't understand what's happening. It'll just keep pushing it out and you'll get pockets of air because the nozzle's bigger than the actual what it expects to be pushing out. The flexible, I'll put the instructions on how you can use that. User beware on that one though. Okay. Jump onto the websites with those ones there. I will dive in now quickly and share my screen for that, just to give you a bit of an idea of where they are. Where is it? Oh, it's a window I'm after. And it should be that one there, is it? Right, okay, so on the marketplace.
That's your Teams window.
Oh, got to pick the wrong one. Thanks, Stuart. Yeah.
Just while you're working that out, I've added in the chat a good little web page that talks about the differences between ABS, PLA and PETG.
Thanks heaps for that. It's really cool. So on the marketplace, this has just dived into AdBuy. You will find that if you throw in filament, you will see that there's Bilby filament in here. At the moment, you will find that most of them are the 600 gram spools because they're suiting the inventor. Both suppliers are getting the 1 kilo spools on here as soon as they can, ready for you guys, because hopefully the spools that you've got in there will last you a little bit of time and we should have them in here ready to go. Here's some 1 kilo spools starting to go in there. Now, this is Ray's 3D. It's quite a high-end product, and they are really good printers. If you've really got some dollars and you want super high-quality printers, they are amazing. But you will go through, and the MTA one comes up as well. I will dive in on the Bilby website, and here you've got filaments. You've got PLA, PETGs, there's Flex, ABS. You can also get in some reinforced, fibre reinforced, the cellulose, carbon and glass. Interesting, if you jump onto the YouTube and have a look at these things, you will find that there's quite a bit of evidence that these will not give you a huge amount of strength advantage, if at all. They are rather an interesting idea. And the look, especially the carbon, doesn't look like carbon. You need to have the mat to lay it down to make it look like those clever things that they put on cars, etc. Metal filaments are the brass, bronzes, etc. The dissolvables are rather interesting. Again, you use those with twin head printers, the DX printer from Bilby and the Raise printers, for example, and there's a few other examples. That would allow you to have one nozzle with the PLA, ABS, etc., and your supports would print in the PLA. PLA is like the PLA glue. At the end of the print, you take that, you throw it into a bath of water, and the PLA dissolves. So you don't have to crack off your supports. It does that for you by melting. Next, when I'm back next term, I'm going to go through supports and alignment and how to go through and make that work to get the best and efficient way of printing, because it's one of the things that can really muck you up. Big spools, you can get 8 kilo spools and then use a little roller on the outside of your printer and put that in that way. And so there's a few different ones in this, especially, and resins if you get into resin film printing, which is a whole other area to get into. MTA also have their website, and here you are, the Flash Ord PLA. I'm pretty sure this is a 600 grams, so it's a little bit more expensive at MTA, but we're kind of used to that as well. MTA have their products sitting on here at the moment. They also have their printers. If you dive into the marketplace, you will also find that the printers are available. I think they're just over $1,000 with Bilby at the moment. So that would be, you were looking at purchasing. Let's see what we've got. $1,015. And for this particular printer, that is a ridiculous. There's the IDX version. This is the twin head one here, which is rather interesting. Doesn't have the same print area as the Adventurer 4. It also doesn't have, from memory, it doesn't have the removable print nozzles like it is in the Adventurer. My understanding is, although that's the Pro 2, it might. I'd have to have a look and check on that one. I did know that they were looking at adding this on, and I think it will become a very standard thing for them to use. That'll be interesting if it starts doing something. They want to use this nozzle replacement technique, I think, in all their printers because it is an actual game changer. But they will print, the IDX printers, they will print together, or they will print, oh, you can't see my hands because you're looking at the screen. They will print exactly the same duplicate. They will mirror it, or completely independent. They can have two different things. The other thing that I'm going to go through with the next episode is how to gang up and put multiple prints on the one print job using the flash print software. So that'll be one of the things that we look at as well. So I think that basically covers us for today, and I'm going to leave that there unless somebody wants to chime in with a question, and I'll let you have an early mark. Any questions at all? Turn your microphones on, everyone, if you want to have a bit of a chat. We tend to do that a little bit afterwards anyhow. And if you've got any questions or any clarifications of what we've done today, just let us know. Suda? No one? We might call it a day. Okay then. All right, thank you very, very much. Check this one out again if you have anything. I do have the chat up, don't I? No, I've got transcript up. Right, okay. That one's there. Oh, good. We've got a poly and our PETG and Aquafingo. Excellent. Okay then, guys, have a great holiday, please. Take your printer home and play. I will encourage you to do that. Give yourself a chance to do it. Let your kids have a bit of a play with it as well, because they will discover things that you're not going to discover. Become familiar with it, and we'll see you back next term bright and refreshed from having a bit of a break from teaching. Thanks very much, guys. Bye.